Hello everyone, my name is Aslanur Demirkol. I'm a master's student at Özyeğin University's Design, Technology and Society Department, and today I will be presenting my article, A Critical Review on Textile Waste as Construction Panels and Bricks, at the 20th International Conference on Design Principles and Practices. This paper proposes that textile waste has a great potential for reuse as construction panels and bricks to reduce the excessive textile waste and construction material production and waste. It also aims to take a critical approach to the disadvantages and advantages of existing solutions. Therefore, this paper examines the textile waste usage as a construction material in production, questions the ways of textile waste being upcycled as construction panels and bricks, and discusses the combination of both industries offering a more sustainable outcome as a construction material, meanwhile examining the production process and resource usage. This critical review will address the global textile and construction waste problem, emphasizing the need for sustainable practices that utilize textile waste and can be incorporated into the construction industry, while delivering existing startups, commercialized companies, initiatives, and design studios, and conducting a critical review and evaluation of the particular initiatives and how sustainable these upcycled materials are. A literature review was conducted using the databases Web of Science, Scopus, and Google Scholar. The keywords used during the literature review were textile waste, ready-to-wear clothing, textile waste as a construction material, textile waste upcycling, construction bricks, and construction panels. The company's social media accounts, including Instagram posts, websites, LinkedIn profiles, and YouTube videos related to the projects, as well as the deliverables of various exhibitions, were examined to obtain further information about the initiatives and their proposed material processes. Additionally, comments on the company's or the initiative's social media were also considered to understand people's thoughts and perception of these products, thereby establishing a connection between their perceptions of upcycling and how they view these companies and their products. Based on the information on different brands and artists, the products were analyzed by their primary materials, textile waste type, additional materials, if disclosed, the binding agent used, production process, material properties, and the areas of use. The initiatives and firms, Fabric, Ackermans and Waste Creates Fabric, Straight, Upsurk Textile and Fashion Bricks Private Limited, Refabric Innovations, Textile Refuge, Wendy Andrew, Feltouch Acoustics, and Sandra Junel's Junel were found. Since the research focuses on examining the construction materials and bricks that are made from textile waste, Feltouch Acoustics, Sandra Junel's Junel, and Wendy Andrews' works were excluded. This part will be mentioned in detail in the upcoming slides. Approximately 92 million tons of textile waste are generated worldwide each year. Between 2000 and 2015, textile production doubled, while the average lifespan of garments decreased by 36%. Recognizing that the fashion industry not only utilizes cotton but also incorporates other natural or synthetic fibers, the fibers that are not recycled are a concern. According to Euromonitor International, the amount of textile waste recycled in EU countries from 2019 to 2025 in tons was 1,143.4 tons in 2019 and 952.6 tons in 2025. One of the main reasons is that the industry rapidly manufactures clothing in response to trends, keeping the fashion brands alive. Another reason is that the growing demand for clothing, fashion trends, and fast fashion, which is most preferred, has also significantly increased the production and consumption of clothing. It is forecast that global textile waste will grow at an annual rate of 60% between 2015 and 2030, resulting in an additional 57 million tons each year, bringing the total to 148 million tons. And when textiles are no longer in use, or not recycled or upcycled, they are either landfilled or incinerated, resulting in a global textile waste rate of 73%. As shown in the graph, according to Statista, The annual total quantity of incinerated textile waste per person in the European Union in 2016 is that Belgium is the first country incinerating 3.7 kilograms of textile waste per person, followed by Czechia, Portugal, and Spain, which incinerate 0.5 kilograms of textile waste per person annually. According to another statistic that is provided by Statista, the annual total quantity of landfill textile waste per person in the European Union in 2016 again starts with Belgium with an amount of 6.4 kilograms, followed by Czechia with an amount of 5.8 kilograms, and Spain being the last one with an amount of 1.2 kilograms. Demands on construction materials. Along with the textile industry, the construction industry also has a profound impact on the environment. In Europe, the construction industry consumes a significant amount of energy, and according to Statista, 38.43% of waste generated comes from it. Additionally, construction and demolition activities produce more than 11 billion tons of waste, with concrete debris accounting to roughly 50-70% of the total annually. Thus, as the construction industry generates rapid waste and demand for construction materials continues, ongoing studies focus on developing alternative materials to serve as solutions for construction activities and as replacements for traditional clay or cement-based bricks. Given the rapid production of textile waste by the textile and fast fashion industries and the emerging and ongoing demand for sustainability, it is crucial to adopt more sustainable practices for the utilization and repurposing of textile waste. Therefore, the construction and textile industries have the potential to utilize textile waste in construction to reduce the negative environmental impact generated by both industries. The initiatives and firms Fabric, Ackermans and Waste Creates Fabric, Straight, Upsert Textile and Fashion Bricks Private Limited, Refabric Innovations, Textile Refuge, Wendy Andrew, Feltouch Acoustics, and Sandra Janelle were founded. And since this research focused on examining the construction panels and bricks that are made from textile waste, Feltouch Acoustics, Sandra Janelle, and Wendy Andrew's works were excluded because Feltouch products are used in wall panels, ceiling panels, ceilings, lighting, cladding, hangings, and fillings, which are made from PET felt and advanced fibers through a heat pressing technique. Wendy Andrew utilizes salvage waste in a collaboration with a performance fabric company and uses water-based solvent-free acrylic resin as a binding agent and exhibited them in Dutch Design Week in 2019. And Sandra Janelle's products are about upcycling 100% wool waste by mixing it with a plant-based binder and turning them into custom logos and wall art. Hence, the mentioned names do not use textile waste as construction panels or bricks, but for other purposes. Excluding these names, the rest of the brands were analyzed further. Based on information on different names, the products were analyzed by their raw materials, the textile fiber type, additional materials if used any, and the binding agent used if disclosed in detail in terms of their ingredients as well, the production processes, material properties, and the areas of use. Because it was decided that according to the studies, providing these properties of the companies, the ingredients that they use for production are the most beneficial in terms of producing the material and tackling its usage areas, meanwhile mentioning the material properties. And in this table, I will be providing the details of the initiatives and companies that upcycle textile waste into construction panels and bricks. Fabric is a French company which was established in 2018. The raw material that is used is textile waste, and the textile fiber type is miscellaneous, meaning that this company shreds the textile waste, including the buttons, zippers, or anything that's on the garment. The additional material here is natural binder, and the binding agent, in terms of its ingredients, is a secret recipe, but they call it eco binder. The quantity of the water usage on materials, if there's any, is not specified or disclosed. And the production making technique consists of the company shreds the textile waste and pours them and puts them onto molds and pours the eco binder inside the molds and squeezes the excessive binder manually and takes them out of the molds and leave them for air dry for 10, 12, or 15 days, maybe 2 weeks. The areas of usage are wall tiles, accessories, and furniture, and the material is durable, strong, and insulating. And the eco binder that they're using in their textile waste bricks, the company states that the binder that they're using makes the bricks fire resistant. As for Wastecrete and Ackermans collaboration fabric, Ackermans is South Africa's largest clothing chain of retail stores, and Wastecrete is an affiliation of World of Decorative Concrete. This collaboration was made in 2021, and the raw material that they're using is textile waste shredded. And the textile fiber type is miscellaneous, meaning that similar to fabric, they shred the textile waste, including the buttons, zippers, and anything that's on the garment and the textile itself. The additional material here is used cement, and the binding agent is water, aggregate, and chemical additives to make the cement. The quantity of water usage is not mentioned. Their making technique consists of preparing the cement, applying the shredded textile waste inside the cement, pouring it and mixing it together, and placing them into molds and baking. The areas of use is ready-to-use bricks for construction, paving blocks, concrete tabletops, and furniture. And the material is durable, resistant to breaking, and stiff. And especially, it's important to mention that the collaboration states that textile waste inside the bricks make them durable and also insulating, as well as making the bricks fire resistant. Straight is a Turkish startup that was founded in March 2024, and this startup repurposes fabric waste into high-performance insulation products, building materials, and packaging solutions. The raw material is textile waste, and the fiber type that is used is package felt, acoustic felt, and composite material. The additional material, the binding agent, the quantity of water usage, and the production making technique is not mentioned. And throughout the analysis, while looking at the website, there were some of the details that were interesting, meaning that the website included AI generated videos. And in terms of the materials, there wasn't any definite material, real life material that was seen on the website. It's a very new startup and it's still on its way for improving itself. The areas of use are construction and insulation materials, package, and acoustics. And the properties of the materials are soft and insulating for package solutions, acoustic solutions, stiff and insulating, resistant for insulation materials. Upstart Textile and Fashion Bricks Private Limited is a government certified startup based in India that was founded in 2025. The startup focuses on repurposing discarded textile waste into construction bricks, utilizing their patented bioresin, which is plant-based and non-toxic, to provide thermal insulation in the bricks. The textile fiber type is not specifically provided, and there isn't any additional material that was provided by the startup. And the areas of use are internal wall panels, false ceilings. And the properties of the material are durable and stiff and rigid. Refabric Innovations is an Indian startup that focuses on upcycling textile waste into blocks and other forms of products. The startup is currently active for more than 4 years now, and they collect the clothing and textile waste from households, schools, colleges, and offices. They sort it and segregate it, and then finally recycle the waste to provide repurposed products. The raw material here is pre-consumer and post-consumer textile waste, and the fiber type is not specifically provided. The additional material here is synthetic coating, and the binding agent that they use is a semi-synthetic binder. The quantity of water usage on materials is not specified, and the production making technique consists of shedding the textile waste and then manually binding it, putting them inside the molds, and leaving them for an air dry. and finally putting a coating on the products. The areas of use are handcrafted wall art, eco-friendly hangers, and sustainable home decor. Handcrafted wall art also includes a brick form of upcycled textile waste. That's why it was included. And the properties of the material are stiff, durable, and rigid, as well as glossy, since there's a synthetic coating as an end material on the products. Starting as a joint project in the academic year of 2023-2024 at IED Milano's bachelor's degree in product design, Textile Refuge is an award-winning open-source initiative by Lilo Studio. This initiative aims to upcycle textile waste and to repurpose it as a construction material to create social value and reduce negative environmental impact. The main idea here is to offer durable housing solutions for displaced people in the Greater Accra region, which faces rapid population growth and a lack of housing quality in Ghana. The raw material used here is textile waste, and the fiber type is non-recyclable textiles and fibers. This is a great detail because most of the textile waste that is currently produced as post-consumer textile waste and post-production textile waste are from mostly non-recyclable textiles and fibers. The additional material used is lime and water, and hence the binding agent is hydrated lime. Mixing lime and water together, hydrated lime is made, and the quantity of water usage on materials is not specified. First, lime and water is mixed together, making hydrated lime, and mixing it with shredded textile waste. The mixture is mixed, and throughout this mixing process, the hydrated lime emits CO2 to the environment. However, placing them in perforated molds, keeping them for an air dry, hydrated lime reabsorbs 40% of the carbon dioxide back. And they call this material Limetex. They are currently refining their construction material, which is called Limetex, through extensive testing to elucidate the properties further. They are testing different properties. The properties of the material are rigid, stiff, and firm. It is interesting to note that numerous startups and companies are working on upcycling textile waste into construction materials, such as bricks and panels. Examining these initiatives, it becomes clear that they all serve an essential purpose, upcycling textile waste into new products. The idea of using textile waste as an alternative material to the existing construction materials seems promising. Utilizing discarded waste materials in brick production not only contributes to environmental protection, but also enables the development of sustainable, visually appealing construction materials. One of the main positive impacts of these initiatives is that they utilize local textile waste, thereby reducing the excessive amounts of textile waste produced by manufacturing parties and post-consumer textile waste, and it is beneficial. These solutions have been available for a while. However, implementing these practices in real life is still entirely new. Although these products hold great potential for the future, they also come with challenges. The bricks are not fully ready for use in construction, as this type of product requires more research and development and prototyping. Therefore, replacing textile bricks over traditional bricks is discussed and debated because incorporating textile waste into each product can change strength and endurance, potentially showing significant differences compared to traditional bricks. Most importantly, according to the analysis of each initiative, omitting the amount of water used may suggest excessive water usage during panel or brick production. This raises the question of whether the material is actually sustainable if it consumes too many natural resources throughout its production process. The amount of natural ingredients is also not mentioned on the aforementioned initiative and companies' websites or on social media, which raises suspicion about the initiative's transparency and the sustainability of these materials, even though they are made from textile waste and repurposed into a new product using a natural binding agent in some of them, allegedly. As for the conclusion, based on the analysis and findings, the intended bricks and panels made from textile waste are still being tested and evaluated to determine whether they are ready for reuse in the construction industry. Additionally, the bricks are not fully ready for use as bricks in the construction industry because they have difficulty with load-bearing capacity and tensile strength despite being good insulators. According to current analysis, most bricks are produced for use in wall panels and insulation. The demand for these materials is still not very known. This could be about people not being ready to change their habits when doing construction, pricing differences compared to the existing materials, or these initiatives not being recognized enough online. Most of the initiatives are still in the research and development stage, and only a few of them have been commercialized. As most of the initiatives are newly established, their resources for reviewing and analyzing tend to be limited, and the details provided may also be insufficient. The solutions that use textile waste as construction panels and bricks are currently open to further study, including examining their water consumption, conducting case studies, and contacting the companies for obtaining further information and detailing this not yet known area. According to the analysis, the initiatives and companies' water emission during material production are not visible or provided, which is concerning and may pose an environmental issue in the future. Thank you for your time, and I would like to answer your questions.